Hello and welcome to InsideWi-Fi, video 31. Before the arrival of 802.11n, earlier Wi-Fi standards used a single radio chain and one spatial stream, known as single input single output. This limited data transmission to one stream at a time. The introduction of MIMO, multiple input multiple output, in 802.11n was a breakthrough, enabling multiple simultaneous data streams and significantly improving Wi-Fi efficiency and throughput. In this video we capture single input single output, single input multiple output, multiple input single output, multiple input multiple output, radio chains and spatial streams. Before we continue, let's clarify a few important concepts. Single input single output, SISO. SISO uses one antenna for transmission and one for reception, making it a simple and cost-effective setup. Common in older or low-end Wi-Fi devices, it offers lower data rates due to the absence of spatial diversity and multiplexing benefits. Single input multiple output, SIMO. SIMO features one transmitting antenna and multiple receiving antennas. This setup enhances signal reliability by mitigating fading through diversity gain, combining signals from multiple antennas to improve reception in challenging conditions. Multiple input single output, MISO. MISO uses multiple transmit antennas and a single receive antenna. By sending the same signal from multiple antennas, it enhances range and coverage through transmit diversity. Multiple input multiple output, MIMO. MIMO uses multiple antennas at both transmitter and receiver to improve link reliability and boost throughput. Unlike SIMO or MISO, MIMO can send multiple independent data streams simultaneously over the same bandwidth, significantly increasing data rates without requiring extra spectrum. Radio chains. A radio chain is a complete signal processing path in a device, including components like mixers, amplifiers, and converters. Each chain is paired with its own antenna, allowing independent transmission or reception. Think of each radio chain as a lane on a highway. The more lanes, the more traffic can flow at once. This is what enables MIMO and spatial multiplexing. A Wi-Fi device radio capabilities is typically represented as PX antennas into RX antennas : spatial streams. Or more simply as PX into RX : SS. Where PX antennas represents the number of antennas the device can use for transmitting data. RX antennas represents the number of antennas the device can use for receiving data. Spatial streams, SS, the maximum number of independent data streams the device can simultaneously transmit or receive. This is the crucial part that directly relates to the performance benefits of MIMO. Let us see this in detail in the next section. Radio chains are often denoted as 2x2 or 3x3, indicating the device has 2 transmit and 2 receive chains or 3 transmit and 3 receive chains respectively. Spatial streams. A spatial stream in Wi-Fi refers to an individual data path that can be used to transmit or receive information between a device, like a router or smartphone, and the access point or router. In Wi-Fi technology, especially in newer standards like Wi-Fi 4, Wi-Fi 5, Wi-Fi 6 and Wi-Fi 7, multiple spatial streams can be used to improve data throughput and overall network performance. Each spatial stream is essentially a separate antenna that can send or receive data independently, leveraging the principles of MIMO, multiple input, multiple output. MIMO technology allows for the transmission of multiple data signals simultaneously over the same frequency band, taking advantage of different paths that the signals may travel through in the environment, like reflections from walls or other objects. This helps increase the overall bandwidth and reliability of the wireless network. Now coming to the radio chain notation, the spatial streams an access point can transmit or receive depends on the last parameter SS. For example, the notations 2x2:2 represents the device has 2 transmit chains, 2 receive chains and supports 2 spatial streams. Similarly 3x3:2 represents the device has 3 transmit chains, 3 receive chains and supports 2 spatial streams. The number of radio chains often determines the maximum number of spatial streams that can be used simultaneously, but this can vary depending on the specific technology and implementation. It's generally not possible to have more spatial streams than the maximum number of transmit or receive antennas or chains. Valid examples are 2x2:2, 3x3:3, 4x4:4, 3x3:2, 4x4:2 and 4x4:3, but not 2x2:3 or 3x3:4. A 2x2:2 access point can send only one stream to a 1x1:1 iPhone. However, it can leverage all of its antennas to optimize the signal and improve connection quality through techniques like beamforming. The more antennas an end-user device has, the better it can hear Wi-Fi signals in the air, which translates into higher transmit and receive signal strengths. For example, Let us say that you use a device that supports 2x2:2 to measure the signal strength in a conference room and you see a signal of -31 dBm. Well, if you try using a device that supports 1x1:1 to perform the same measurements, your signal strength would be closer to -45 dBm, which is a lot weaker. In the next video, let's discuss metrics that define wireless signal quality. Thanks for watching. Do post your comments.